Hi. Well, I know total product, marginal product, and average product concepts are not alien to you. Neither are they difficult. But there are some things about the graphs and relationships that I think students have to know. Okay, so we have this schedule, production schedule on the board. Um, land 55555, which is to tell us that land is the fixed factor of production since its quantity isn't changing. Land here is in acres. I didn't write it, but like land here is in acres, so 5 acres all through. That's our fixed factor of production. And labor is one that's varying 0, 1, 2, 3, 4, 5, 6, 7. Then you have our total product, which represents a sum of all the output produced after employing the factors of production. 82, 85, 40, blah, blah, blah. Average product, output per unit of variable input. We've defined it like in the previous lesson. And marginal products, the additional output produced from the usage of one more unit of variable input. So in this case, variable input is labor. So it's going to be the additional output produced when one more unit of labor is employed or worker is employed. So what we have to do here is that we have to like sketch graphs of TP, AP, and MP. Right. So if you are given questions like this, then that means you need to draw a graph to scale. But if you don't draw a graph to scale, then that means you are not likely going to get the kind of slope that you should get and all of that. But before we get into that, there are like three different stages of production in the short run. And why is it short run? Remember that short run is a period where there's at least a fixed factor of production. And since we have a fixed factor of production here, so that means okay, this is short run. So that those three stages, we have a stage of increasing return. So increasing return is just the stage where um, a percentage change in input gives a larger percentage change in output. Then for decreasing returns to scale, right, is that like describes a situation where percentage changes in input lead to a lesser percentage change in output. So output is still going to grow, but like it's going to grow less. So if you double your input, for example, that's an increase of 100% in your input. Output might just grow by 35%. So inputs went up by 100%, but output is increasing by 35%. So you're experiencing a decreasing returns to scale or like decreasing returns anyways. Then there's this third one, the negative returns. So this is where or it describes the situation where a percentage change in in inputs, like your variable input anyways, because fixed factor is fixed, so it is variable I can change. So a percentage change in your variable input causes a decline, right, in output produce, like a decline, then that makes it negative, cause a negative growth in your total product. So how do you now know where your variable factor of production is yielding increasing returns or decreasing returns, constant returns or negative returns? So what we need to check is our marginal product. So for you to answer that question, you need to check your marginal product. So and then you know what marginal product is. If I were to employ you, for example, and say come and work as a bakery. I love using the bakery example, like it's kind of easy. And then I employed you and you produce 200 loaves of bread. That's your marginal product. That's your additional contribution to the advancement of my bakery. Okay, so if I employ a second person and the person gives me 250 loaves of bread, so that's the person's additional contribution to the advancement of my bakery. So you brought in 200, the person brought in 250. Adding two of them together, that's 450. Okay, so total product becomes 450. Whereas the first marginal product, the MP1, which is your own MP, is 200 loops. MP2 is 250 loops. So that more or less the reason why it is said that total product is the sum of the marginal product. So just do 200 plus 250, then you get a 450. It's not always like that. So the complete formula, like I told you in the previous lesson, is sum of the marginal product times change in variable input. So you should always do that. All right. So what if this was 10, 20, 30, 40, 50, whatever? So if the change is 10, so that component of your change, I did something like this. Said that your TP is sum of your MP multiplied by change in your variable inputs. Not var input, please. Variable. I don't want to write it in full. Which was an example. Please don't put var. It's variable. All right. So looking at where do you have increasing returns, all those if the second person I employed um, produced more bread, that you did, then that's increasing returns. So like second worker, there's increasing returns on the second worker. That is 200 increase to 250. So if I bring in a third person, the person does a 320, that means increasing returns continues because 320 is more than the amount that immediately precedes it, which is 250. But if I bring in a fourth guy, the guy does a 300, that's already decreasing returns to scale or decreasing returns generally because you are doing less than the person that's you met like than the previous person, like person just before you. So that's that. So looking at this schedule, where are we experiencing increasing returns? 80 is more than dash, right? 200 is more than 80, 260 is more than 200, 400 is more than 260, but 80 is not more than 460. So all this region from the first worker to the fourth worker, increasing returns. Okay, let me just call it increasing returns. And why? This is simply because the marginal product successively increased. So the marginal product along that range of employment, that's along the range of employing these workers, successively increased. First worker gave you something more than when there was no worker. Second worker gave something more than when there was just one worker. Third worker gave you more than what the second worker did. Then fourth worker. So that's it. So there are we then experiencing decreasing returns. Um, 80 fell, right? Like 460 fell to 80, so this is it. And 80 dropped to zero. So these two parts now is decreasing returns. And of course, this Aboki here is our negative returns. So you can see, so three stages. So this is stage two, stage three. I believe you know what um, law of proportion says, which is otherwise known as law of diminishing returns. Okay. As more and more factor of production is continuously added to a fixed factor of production, output initially increases and eventually falls. Okay. So variable factor of production is added to a fixed factor. That's short run, right? So it's the output there is talking about a total product. So as more and more of a variable labor in this case is added to a fixed factor on land. It's not always like this, right? This can be fertilizer, can be cement, can be anything. Like just be careful. All right. So, but in this case, labor is variable. As more amount of variable factor product is added to a fixed factor production, output that they're talking about there is the total output. That is the total product. So initially it increases. 80 keeps increasing to 1080. Still 1080 here, and then it falls. 980. That's the fall. It falls. So as more and more of a variable factor of production is added, so if this factor of production, output initially increases and then it falls. Okay. So I want to I want to show you the relationship between TP, MP, and whatever. So I'm going to I want to draw TP first. What's the lowest number for TP? Lowest number is 80. Highest number is 1080. So I could do 1 centimeter to 100 units. Okay. So let me just do. I hope my graph. Do you have a negative? That cannot even be negative. As well, it's going to be zero. And then we have here. So yeah, when labor is one, this guy is 80. Labor is one. This is 80, maybe around here. Then two, 280. Two, 280, maybe around here. Then three and 540. Three is join all these points together. Okay, let's manage it. That looks like a fair effort. Okay, so I can't extend this here because I don't know. Let's do it like maybe this way. That's a fair effort to be honest. So here, labor. Because labor is a variable input, so we drew it to transfer to labor. So yeah, this is how our tabular is supposed to look like. So what I really wanted to do was to draw marginal products right below it, but I guess I just have to like do it um above it, and then we show some things. We show ourselves some things. I prepared our sheet, so our space for us to like draw the MP and the AP curves. Yeah, so I figured that the lowest number for the AP and the MP was 80. And lowest number was 80, and okay, lowest number is actually minus 100. Minus 100. So I could just like extend this and make this one like a random minus 100. It's meant to come below that, but like let's just leave it that way. So like let's begin to like plot. I believe you have the data. For AP, no, for MP rather, 1 and 80 when level was 1. So I was 80. So 1 and 80. And next 2 and 200. 2 and 200. Sketch out our MP. No, something like this. So normally, if you check your textbook like MP, it's just something like this. But it doesn't really have to always be that way. So that's our MP. What are the data set that you're given? Then let us sketch out our um, AP. So for AP is also starting from 80, 180, then 2, 140, 2, 140 is just here. I didn't draw this to scale to like, there'll be like some errors. Then 3 and 180, 3 and 180. We have something like this. So this our graph is a little bit unique, you know, but then it's fine. So what are the things I really want us to see? Under normal circumstances, MP is supposed to touch AP at AP's maximum. So like this graph is a little bit problematic. I hope you get that. So MP, AP is equal to MP at AP's maximum point. Its maximum point. So that I just want us to like know that. And this one is, like I said, it's not so drawn to scale. I tried, but then some things are just the way it is. So let's look at some relationships between. If you first look at relationship between MP and AP, so what can you say? The first one is that as MP rises and falls faster than AP, like that's the first thing. It's a Yahoo boy, like go faster, die faster. Right, so it's rising faster and falling faster than AP. That's one. The number two, the second, what I said there, that MP is equal to AP at AP's maximum. It's not really showing here, but like that is it. That is it. So it's not meant to just call this guy. It's meant to be at the top of AP. Then when MP is negative, at this point, MP is now minus 100. When MP is negative, AP is still positive, though falling. So when MP is a minus number, minus, right, AP is falling, but it is still positive. So like those are like three relationships between MP and AP. First, MP rises and falls faster than AP. Then MP cuts AP at AP's maximum point. Then when MP is negative, AP is positive, though falling, right? So what then is that relationship between MP and TP? So first thing, but the most obvious thing is look at this point. At the sixth level of output here, right? TP is at maximum. Although it's the same thing for this one too. Like at fifth level of output is also maximum. But the general consensus is that whenever MP is zero, if your marginal product is zero, total product is at its maximum point. So when MP equals zero, then TP is at its maximum point. Or let me say TP cap is already at its maximum point, like a cap on it. Alright, so when MP is 0, TP is at its maximum point. Now look, if you look at it, at the beginning when MP was rising, as MP was rising at this point, TP increases increasingly. Look at it. From 1 to 4, MP was rising. MP rose from the first to the fourth employee here. And look at the way TP was going to from the first. This is 1, 2, 3, 4. This is the first employee. So like this is kind of steeper. So that part is like this, a very steep, no, a steep part. But then when it was coming to the fifth one, then it was becoming gentle. This one is steep. This one is gentle. So when As MP was rising, or as MP rises, TP rises at a faster rate. As MP rises, TP rises at a faster rate, or TP increases increasingly. So as MP is increasing, TP increases increasingly, right? So like I just mentioned, it's fast movement all along the region where the sun is increasing. As MP is falling, but not yet zero. So MP fell from here to here to here, but not yet zero. TP is still rising, like all of this part is still rising, but at a decreasing rate. So as MP is falling, but not yet zero, CP is still rising, but at a decreasing rate. So you can't compare the increase between here and here to the increase between here and here. This one is small compared to how it has been jumping from the beginning. So as MP here, MP is the one that is first, because I used to correct students when they're writing these things. They've been writing as TP is rising, MP is rising. Like, what's this? MP is the first thing, right? So TP is what happens after MP has happened. So as MP is rising, TP is increasing. No, as MP is rising, TP is increasing increasingly, or at a faster rate. Now, as MP is falling, but not yet zero, it's important to put that falling, right? But it's not yet zero. What's happening to your TP? Your TP is increasing decreasingly. It's increasing at a decreasing rate. So all of these parts, it's just increasing small, small. Now, when your MP is zero, of course, TP is already maximum. Then when your MP is negative, then TP is falling. So you can see MP became minus at level 7. So it's the same thing here at level 7. This is now a drop, a fall. So those are the relationships that exist. Now, I wanted to like tell us about stages. You see all of these parts where this guy is increasing here, that's the stage 1. All of these parts from here to here, like to here rather, stage 1. So that's where you have the increasing returns to scale. That is from here, from here to here. So you can just divide it. 1, 2, 3, 4. So it's slanted. So all of these parts is your increasing returns to scale. Then when it started falling, so it goes to this point. So this is the second part. This is stage 2, where you have decreasing returns. So stage 2 covers all of these parts like this. So this is number 6. So you have decreasing returns to scale. And then stage 3 is what is left. Stage 3. So your marginal product is now negative. So the rest here, stage 3. So that's where your total product is falling. So that is where you're having returns. Negative returns. So I just wanted to like point that out. Increasing returns, decreasing returns, negative. So if you're browsing, you see things like this. Increasing returns, just they break the TP. They break TP into 3 to show you increasing returns, and negative returns. So I've done it here, and you've seen the way it works. So it is actually it's a conclusion, or it's an inference drawn from what's happening to your marginal product. Marginal product determines the movement of your total product. So and the marginal product still kind of determines the stages. So because increasing return, we've explained, is the contribution of an additional variable factor production. Is it more than the previous one? Is it lower than the previous one? So yeah, that's it. So in case there is any question, let us know in the comment section. So I appreciate you for watching this video. See you when I see you. Thank you.